Hi, I am pre-recording the PowerPoint for water availability, section 1.4. You guys will be watching this, filling in your notes in your packet, pages 14, 15, and 16. You'll have to pause things along the way and write some notes down. And then we will talk about it in class during the period today, which is September 18th on Friday. So I wanted to show you that I am wearing water earrings today. A student made these for me. Aren't they so pretty? Can you tell how it's water? H2O. So there's two H's, the little white ones, and then the O is an oxygen, and they're actually kind of the right structure there. Water molecules are like that, and water is really important in environmental science. So let's get started. So here's where water is important, and these are things that you should be writing down in your notes in this little box right here. Water is vital for all life. We would die without water. So that's really one of the very, very important things for humans is that we can drink it. But most of the problems and issues and things that we use water for are different than drinking. Okay, so we need to keep that in mind and get a sense of how much water there is in the world and where it's being used and how to keep it sustainable. So it moderates the climate, it sculpts the land, it removes and dilutes waste and pollutants, and moves continually through the hydrologic cycle. You may need to pause so that you can write that all in here in this box. I'm going to move on. Now this picture helps you understand the size of the earth and the amount of water in the earth. So you can see a globe with all the water removed and put into a nice little sphere on top of the United States. So that big sphere, that big bubble, that is all of the salt water in the world. So if you suck all the oceans up and put it into a little drop, that's the size comparison between the earth and the amount of salt water. Now that littler, tinier little bubble there, that is all the fresh water. So that fresh water, that's all the water that we have for drinking, but also for everything else we use water for. And one of the huge things we use water for is for watering our crops. So I think that's a good way to give you a sense of how water distribution is. This is another way to do it. And so what you're doing here is you are going to be looking at in your notes these little boxes here, and you're going to be coloring them in so that they are colored. So that's what you're going for here. And it's a little hard to see this, but you need to take your time and watch these slides and pause and then color it in with colored pencils. All right. So on this one, what it's showing is that the bulk of all the water in the world is ocean water, approximately 96.5%. But then there's three little lines there, right? So one is saline lakes that have salt. Then there's also saline and groundwater. So you need to write that in and say the percentage, 0.93%. And then at the top, that very little tiny top part, and then you can draw in on the very top of the column too, is the fresh water. And that's only 2.5%. So you can draw that in and write in your notes. And then I'm going to move on to taking that little 2.5% and blowing that up into the second one. So please pause if you need to. And now this is that 2.5% blown up, just the fresh water. And of the fresh water, most of that is frozen in glaciers and ice caps. So 68%, almost 67% is in glaciers and ice caps. Now groundwater is 30%, and groundwater I'll explain to you more in just a minute. Surface water and other fresh water, those are things that is more accessible to us and that we can use for irrigation. This water is only 1.3. Now we're going to blow that up. So take your time to color in this column in your notes. And when you blow that up, now we have the atmospheric water, the biological water, like the water that's in living things, the rivers, the swamps, the marshes, the soil moisture, lakes, and ice and snow. So we really don't have, of all the water in the world, we only have a little bit that we're really working with. Groundwater we can pump out of the ground, and you'll see that in just a minute. And that's where we get a lot of the water that we use in our homes. So that will take you a minute to write all those things down and color everything in. So you can pause, and I'm going to move on. Now, the thing that you write in the little bubble, the little circle right here, only 0.02% of the Earth's water supply is available as liquid fresh water. We have to treat this water so preciously because it's precious. Okay, so the next thing that you can do in your notes on page 16 is this activity called Here's Where the Post-Apocalyptic Water Wars Will Be Fought. Because if you think we're fighting over oil, wait till we start fighting over water. So you're going to go to that link in the packet, which you'll have to go to the link in Google Classroom and open the PDF to click the link. And there's a copy of this in the Google Classroom. So during class today, you can ask me about that if you're not sure where things are. Okay, moving on. So here, back on page 14, you have a picture of the water cycle. The water cycle is like the nitrogen cycle and like the carbon cycle and the phosphorus cycle and the sulfur cycle. But the water cycle is the thing that actually moves everything around, right? Because the chemicals are dissolved in the water. So it's very important to understand the water cycle because it's really an incredible force for nature. You have your classic evaporation, condensation, precipitation. And another very important one here is the evapotranspiration. That is water that's actually coming off of plants. So that also adds to water in the atmosphere. And how this water cycle runs is just really important to understand. So we're going to learn some more about all of these terms on this water cycle figure. You know what runs the whole water cycle? What makes it move? Do you want to guess? What do you think it is? You know what it is. Scream it loud. The sun. The sun is what's actually making the water cycle move because of evaporation. So we're going to talk about what happens when there's more heat trapped and there's more evaporation with global climate change. Okay, so you have this picture. And now we're going to talk about the flows and throughputs, okay? So this part here is where you're filling these things in, okay? So you probably need to take a little bit of time, and you're comparing it to this figure, all right? So infiltration, runoff, plant uptake and transpiration, seepage, precipitation, and then those things are all here in the picture, so you should recognize that, maybe go through and identify them all in here and make sure you understand them. And in the picture, we don't have drinking and we don't have percolation. But really, the amount of water people drink doesn't change the whole hydrologic cycle as far as we're looking at it for the whole Earth. Okay. So you also have transformational processes like snowmelt, evaporation, sublimation, freezing, condensation, and fog drip. And then you have climate change effects. Precipitation can increase or decrease, droughts or flooding, sea level rise from melting ice caps and thermal expansion of the ocean, loss of ice and habitat and freshwater sources like glaciers, and groundwater depletion. And then other human effects, there's pollution, chemicals, toxic metals, endocrine disruptors. Oh, wait, I love talking about endocrine disruptors. I got a lot of stuff to tell you on that. Eutrophication, we know that word. With an excess of nutrients, you get eutrophication. That's a big one. That's a problem coming from the nitrogen cycle and the phosphorus cycle. And then there is thermal pollution. And then the stores are the ocean, that's the largest store, the lakes, rivers, snow, clouds, atmosphere, biota, the living things, and the groundwater. So pause and write those down in your notes on page 15. So here's some important water vocabulary. And this is on page 16 in your notes. Okay, so you're writing these down here. The first one is aquifer, and then the last one is watershed. So you're writing those all down, and then in the next slides, I'm going to be explaining those a little bit. So pause this and write down each of these things right here in your notes, and you'll see they'll match it. Pause, write them down. Okay, so the first one we're talking about is the groundwater. Okay, and the groundwater is water that's in the ground. Hey, that's nice, right? So precipitation infiltrates the ground and is stored in soil and rock. The surface runoff is water that doesn't sink into the ground and it runs off into bodies of water. Please pause and look at these anymore if you need them. The watershed or draining basin is the land area that delivers the runoff, sediment, and any other dissolved substances in the stream. I'll show you some pictures at the end here that show you that most of California really is a watershed. So then an aquifer. Aquifers are really important to understand. It's an underground layer of porous rock that is where we get a lot of our water. So one of the most important aquifers is in the middle of the United States. The largest aquifer in the world, I have a hard time saying it, is the Ogallala aquifer. Don't worry, we'll talk about it later. You can make fun of me trying to pronounce Ogallala. Okay, so aquifers often are misunderstood that that's like a swimming pool underground. Like it doesn't fill up like a swimming pool. It fills up like a sponge. That's a better way to look at it. So aquifers are very important. The water table is the level below which water in the ground is saturated with water. And then you have a confined and unconfined aquifer. All right. So unconfined is with the permeable water table, and confined is bound above and below by less permeable beds of rock where the water is confined. Let's see if I can move. Oh, shoot. Sorry. It's kind of covered up there. Unconfined underground water. So some aquifers are replenished by precipitations and others are not. So an artesian well is another important concept to know. So this is pressure from confined aquifers pushes the water up at a location without a pump. So this is a great way. You can drill into an artesian well and you just get water coming out all the time. So that's a great way to get water. If you live somewhere where geologically there's an artesian well, you can just get water flowing out, and that's a great way to access fresh water. Now we're going to talk a little bit about watersheds and how those work. So I'm going out of order. This is watershed. We had water table. So if you're trying to follow along with the important water terms, it is out of order. So I think you can figure it out. All right. So I'm going to show you from a Google Earth image the watershed that is California, right? Most of it, most of California is a watershed. So let me show you how this works. So basically, the mountains, it snows in the mountains, and then the water runs from the mountains out to the bay and out into the ocean. So this is our watershed, really important. And you can see here another image of a topographical map where you can see that the Great Valley, the Great Basin, that's ends up being where we have a lot of our fruits and vegetables being grown because there's really great soil and there's plenty of water. So plenty of water cycle diagrams, other ones for you guys to look at and have access to. Your textbook is going to be a good resource for these things too. So as we're going through and learning more details, I'll fill you in. Okay, so the next thing we're going to talk about and that you're going to actually write in your notes, and it's really the last thing before you take a little quiz to make sure you understand things. And that is this part right here, where we're asking, how does climate change affect the water cycle? Well, climate change leads to more fires because it's going to be drier and hotter. Climate change leads to more droughts because some areas it's going to be wetter and some areas it's going to be drier because there's only so much water and it's about how it moves. It also makes for bigger storms and hurricanes, all of which, unfortunately, we are living through right now. We've just gotten out of a drought and we are living through breathing the smoke and hurricanes in Florida. So there's more or less precipitation leading to flooding and drought. So this is what you're actually writing in here. There's increased irrigation and uptake required because things are dry, so we have to pump more water out of the ground to water the crops or to get water to people's homes. There's a loss of groundwater and depleted aquifers because we have to access more groundwater when there's not as much on the top of the ground. There's a decrease in land and sea ice because it's melting. And then we have sea level rise. And when you melt ice caps, we'll talk about land ice versus sea ice and how that changes. These are all things that are absolutely going to happen as the earth warms, and we're seeing these effects right now. And so this is one of the reasons why it's good to mitigate and slow down our impact on the greenhouse gases in the atmosphere because it is changing the water cycle. So remember I had said that there was a bucket of kittens? I have the bucket of kittens now. It makes more sense too because a bucket holds water. So now the bucket's going to hold kittens. So here's what you should do now. I will show you those answers in just a moment, but you should take the quiz on page 16. And then as we did before, we will have you guys get into breakout rooms and discuss things that you may have missed. So pause, take the quiz, and then I'll show you the answers. Now I'm going to show you the answers. There they are. So 1 through 6, those are the answers. Check, make sure you got them right, and come to class and ask me questions. Bucket of kittens. Happy Water Day.